Okay, let's go. Right, let's have a look. A rocket is fired vertically upwards from the ground. The distance in feet that the rocket travels from the ground after t seconds is given by that. Find the velocity of the rocket 3 seconds after being fired. So the velocity will be upwards. Let's calculate the derivative. Vt equals minus 32t plus 560. So V3 equals minus 32 times 3 plus 560. So that's 464. So it's 464 feet per second upwards. Okay. Acceleration would be the derivative again, which is minus 32. So that's 32 feet per second downwards. Okay. 154. A ball is thrown vertically downward with a speed of 8 feet per second. That should not be broken there on a new line. From the top of a 64-foot tall building. After t seconds, its height above the ground is given by that formula. So its height above the ground. Okay. Determine how long it takes for the ball to hit the ground. So that's just a matter of solving st equals 64. So that means minus 16t squared minus 8t plus 64 equals 64. Cancel, cancel. Divide by minus 8. So that's 2t squared plus t equals 0. T have I made a sign mistake? 2t plus 1. No, I've done something wrong here. A ball is thrown vertically downwards with a speed of 8 feet per second from the top of a 64-foot building. After t seconds, its height above the ground. I highlighted and everything so I wouldn't make this mistake. 0. Height would be 0. Minus 16t squared minus 8t plus 64 equals 0. And we can just use the quadratic formula or whatever we desire to solve this quadratic. And we'll get two answers. T equals minus 1 plus root 65 over 4 seconds. And the second answer is the negative answer, so we'll just go with the positive answer. Okay. And its velocity, well, it's downwards at least, and the derivative is minus 32t minus 8. So the velocity at minus 1 plus root 65 over 4. Okay, so just sub that in. Okay, it's downward minus 8 root 65 feet per second downwards. Okay. Sure we're still recording. Yep. 155. Let's be careful this time, Stephen. The position function represents the position of the back of a car backing out of a driveway and then driving in a straight line, where S is in feet and T is in seconds. In this case, ST equals 0 represents the time at which the back of the car is at the garage door. Okay, and S0 is -4. Okay, so if we just want to kind of sketch this out a little bit here. Okay, so what's happening is this is the back of the car, and this is when T is 0, S is -4. Okay. Okay, so we're measuring the S position from there. Okay, all right, fine. Determine the velocity of the car when ST is 0. So I think I should find the T first. T squared minus 3T minus 4 equals 0. So it'll have to be the positive answer. I can factorize that, can't I? T minus 4, T plus 1 equals 0. So that's at 4 seconds, right? Okay. So the velocity is 2T minus 3. So the velocity at 4 will be 8 minus 3. So that's 5 feet per second out of the garage. Okay, and determine the velocity when ST is 14. So I'll have to solve ST equals 14. So that means T squared minus 3T minus 18 equals 0. 6 and 3, T minus 6, T plus 3. So that's T equals 6 seconds. So V6 would be 2 times 6 is 12. 12 minus 3 is 9. 9 feet per second outwards. Okay. Let's check the answers so far. So this, what are we on? I can check 153 and 155. 153. Oh, whoops, wrong chapter. 153. 5 and 9. Oh no, there it is. 464. Oh, forgot my square. Feet per second squared. Acceleration. 464 and minus 32. Okay, great. And then 154. I don't have the answer here, but that's the time answer, and then that's the velocity answer, and that is feet per second. But 155, I can check 5 and 9. 5 feet per second, and it should have included like some reference to direction, but I guess the sign is the direction, so that's okay. And 9. Okay, that's great. That's great. Let's have a look at 156 now. Need a bit more coffee. All right. 156. The position of a hummingbird flying along a straight line in t seconds is given by that formula. Okay, so that's st is 3t cubed minus 7t. So the velocity would be 9t squared minus 7, and the acceleration would be 18t. Determine the velocity after 1 second. So the velocity after 1 second is 9 minus 7, so that's 2 meters per second squared to the right. So I'll just emphasize that by putting a plus here. Determine the acceleration at 1 second. So that's a plus 18. Oh, why did I say squared? It's meters per second squared. Determine the acceleration of the bird when its velocity is 0. So let's answer. Velocity 9t squared minus 7 equals 0. So that means t is root 7 over 9, which is root 7 over 3. So the acceleration would be 18 times root 7 over 3, which is 6 root 7, and it's again meters per second squared. Velocity after 1 second, acceleration at 1 second, acceleration when the velocity is 0. Yeah. 3t squared 18. Yeah, the bird's just getting it's kind of interesting that the bird, it's heading like its position, it's kind of doing something interesting. It begins when s is 0 here, because if you put in t is 0, you get s is 0. But note that it's really weird. When you put in t is 0 into the velocity, you get minus 7. So the bird is heading backwards. It's slowing down. It stops and then starts heading forward. So it's going like that. Okay. That's 156. So there's no answer there. Okay. And then 157. Okay. Okay. A potato is launched vertically upwards with an initial velocity of 100 feet per second from a potato gun at the top of an 85-foot tall building. The distance in feet that the potato travels from the ground after t seconds. Okay, I better draw this now. A potato is launched vertically upwards with an initial velocity of 100 feet per second from a potato gun at the top of an 85-foot tall building. So it goes up and will come back down, I'd imagine. The distance in feet that the potato travels is given by this. From the ground? From the ground? Oh, I think this is meant to say position, not distance. Because you can't say the distance from the ground because it didn't start from the ground. It started from the top of the building, right? Yeah, I think this is wrong. We'll see what they ask. So ST is minus 16t squared plus 100t plus 85. BT is minus 32t plus 100. AT is minus 32. And technically speaking, I would prefer the t to always be less than 3.125 seconds, because it doesn't really make sense if it's distance for the s to start decreasing, which is what will happen when t goes beyond that number. Let's see what happens in the question though. No, okay, so we're already straight into the first problem. So okay, that definitely should say position. A, velocity at 0.5, and then the velocity at 5.75. All right. $84 feet per second up. And then minus 84. So we'll say 84 feet per second down. B, find the speed of the potato. That's 84 feet per second for both cases. C, determine the potato has reached its maximum height. That happens when BT equals 0, i.e. t equals 3.125 seconds. D, find the acceleration. Well, that's 32 feet per second squared downwards. E, determine how long the potato is in the air. So that's when st equals minus 84. So that means minus 16t squared plus 100t plus 85 plus 84 plus 169 equals 0. So that's t equals 7.63. How many significant figures? We'll just do 2 decimal places. 33 seconds. F, term velocity of the potato upon hitting the ground. So we just want to calculate V of the answer from E. How I should write the full number down. Okay. Okay, so minus 32 times that plus 100. So that's equal to 144.28 feet per second down. Okay. Right, all right. That's A, B, C, D, E, and F. Let's check the answer for 157. Okay. $84 minus 84, 84. 25 over 8. Okay. Yeah, that's right. and then minus, so yeah, that's right. Okay, that's nice that they give it as a surd. I'll check it now. Oh, that's not matching up. I must have made a mistake. Huh, what have I done wrong? 80. Oh, 84. Oh, shame. I wrote 85. 85. So that's 170. Shame. Shame. Okay, let's fix this. Why did I say 84? Oh, because my 84 was mentioned 3 times. My brain was primed for it. Okay. 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 Um, okay. Right, so equals minus 85. Okay. 85 plus 85. Okay. Deter determine how long the potato is in the air. Now, my answer is a little bit different though. I got t equals 25 plus 3 root 145 over 8 seconds. That doesn't match the back. And likewise, my velocity is basically minus 144.5 feet per second down. But it differs slightly from the answer at the back. The answer at the back is not quite the same. So have I done something wrong? Let's double check. Minus 16 t squared plus 100 t plus 85. Oh, from the ground. So it's not equal to 85. It's equal to 0. Again, another silly mistake. Okay. Oh, dears. What's wrong with me today? What's wrong with me today? Just not having a good day. Okay, that should equal 0. Now we're right. T equals 25 plus root 965 over 8 seconds. So T is roughly 7.008 seconds. And then the velocity at the answer for part E would equal okay, that's going to be roughly minus 124.258 feet per second down. But that's the precise answer, and then the precise velocity by the way, would be minus 32 times 25 plus root 965 over 8 plus 100. Okay, I'm sorry. I made a bit of a mess of that question again. I'm just not fully focused today. All right, we'll leave it there today, and I'll see you next time. Thanks for watching.